hope you enjoyed that slog up the hill, but hey, it was well worth it, wasn't it? Because look at the view. Up here on the Port Hills we can see almost all of Christchurch, and it's a good place for a trick station, a beacon. Now what are these used for, Steve?
Well, as Nick talked about this morning, this is a trig station which is used as the base for survey throughout New Zealand, and this one is used for the base of survey throughout Christchurch and Canterbury. Sometimes, even today, even though we have GPS, we still need to refer to this trig station because sometimes the GPS technology doesn't work in very heavily wooded areas, in deep hill valleys, or in urban centres where there are large buildings. So sometimes we still need to use GPS as well. We need to use the trig station as well, which is why we see it here, and you can actually get line of sight from Christchurch to the station.
Okay, so you mentioned GPS. What exactly is it and how does it work?
Okay, GPS stands for Global Positioning System, and in its simplest form, GPS is the splitting up or the segmenting of the world into a grid system. So we call that latitude and longitude, and instead of just having a straight number, we read them off in degrees. But by splitting the world into latitude and longitude, because there's a unique number for each, it's possible to pinpoint any individual location on the planet by this unique numbering system. Now what I've done today is I've actually brought along a little toy that most of us know called battleships. And battleships works off the same principle. So in battleships we put our ships on the board, but we know where they are by a numbered system. So we have 1 to 10 across the top, and we have A to J down the side. And so if I want to find a point on this grid, I can say, okay, what's the point at D4? So I go down to D, and I go across 4, and I can actually find the location on this grid. In the same way we play battleships is exactly the same way that we find our locations in latitude and longitude through GPS.
So those degrees are the coordinates. Very similar to battleship. Pretty cool. Okay, so we've got GPS base stations. What are they used for?
GPS works off a satellite system where satellites are revolving around the world around us all the time. And GPS base stations, like the one that Nick set up for us this morning, is a super accurate way to find your location on the face of the Earth. The way that the GPS works is shown in this picture here. So the Earth is the multicoloured ball in the middle, and the red and the black dots with the orbit lines around the outside are the satellites in orbit around us all the time. So if we think of the GPS base station as this blue dot in the middle, the GPS base station links to a minimum of 4 satellites at any one time, which gives us super accurate readings to the millimetre to know exactly where we are on the face of the Earth.
And you might have seen GPS little receivers that give us that information to tell us where we are. Very useful for things like tramping or even in your car to tell you where to go. Okay, so we've got these things here in Christchurch which are going to help us to know where things are located. But in the case of an earthquake, if all these marks, survey marks, moved, what happens?
That's a very good question. Well, what happens is because the earthquakes have affected such a large area of Canterbury, we've actually had to go wider and wider and wider afield to actually look for some GPS base stations that haven't moved. And in terms of the Canterbury earthquakes, we've had to go all of the way to the Chatham Islands, which is some 600 to 700 kilometres off the coast of Canterbury. So we've actually had to go a long way in this earthquake to get back to a base station that we know, or we're very confident, hasn't moved.
Yes, complicated. Okay, so you might like to go away and find what your GPS coordinates are for, say, your home or school. A little job for you there to find your exact location.